Should be able to do these algebraically without always relying on the calculator. And kudos to Ka. I think you're the one in this class who's done it algebraically. Hannah Vallette did it algebraically in 7th period, and one person in the 3rd period, I think, did it algebraically, maybe 2. So just a little bit about working through this algebraically. Part B is, I think, pretty straightforward. How high is the football when it is punted? And then it says, in parentheses, as a little hint, find y when x is 0. So for part B, Brandon, I'm using your fancy pen. I do like it a lot. If we want to find y when x is 0, we want to know what's the initial height of the ball. When it's being kicked, it's being punted. It hasn't moved anywhere horizontally. So we're plugging a 0 in for x because that's the horizontal distance, and it hasn't moved anywhere because it hasn't touched the person's foot yet. So how high is the ball, Brandon? Yeah. 1.5 feet, 3/2 of a foot. So that's where it's touching the punter's foot. So no, it's not touching the ground because they're catching it, they're kicking it. So 1.5 feet above the ground would be where that happens. So, I mean, not a lot of algebra. You're just plugging in a 0. The next question, part C, says, what is the maximum height of the football? And looking at the picture, we know the maximum height occurs at the top. And in your calculator, there is a maximum function that'll get it for you. But what are you actually finding when you're finding the maximum of a parabola? The vertex. The vertex. Do we know how to find the vertex algebraically, Brandon?
Put it in standard form.
We could put it in standard form, and that's why we did the completing the square, to get an equation in standard form. Do you think completing the square is the best option for this type of problem?
No.
Because there are evil fractions, 3 of them. Maybe 3/2 is pretty nice, but like -16 over 20/25, not so nice.
Aren't each of those numbers a perfect square?
They are, yeah. But that really doesn't help us with completing the square, like the 3/2 isn't. So we'd still have to take out the -16, 20/25. Still have to work through the completing the square the same exact way. So we're not going to complete the square. But there was another way that you can algebraically find the vertex. And how would you algebraically find the vertex the other way?
Find the x-axis of symmetry.
And that axis of symmetry is what formula? Right, and that was actually the first one that we talked about on Friday. When it is in general form, when you have ax squared, bx, and c, and completing the square could be an option, but probably not the best option for you. The other option would be to use -b divided by 2a. It works every time. No matter if you have ugly fractions or nice numbers, it is another way that you can find the vertex. So the axis of symmetry tells how far it goes over. So if we plug in these numbers, again, they're not nice, but we've got 9/5, it's negative because the formula says -b, and then 2 times -16 over 20/25. Now, yeah, you're going to need to use a calculator a little bit because that's pretty tough doing mentally. But when you put that in your calculator, approximately what decimal did you get?
I didn't put it.
Oh, you have it as a fraction. Awesome. What do you have as a fraction?
3,645.
25 or 45?
45.
Over?
32.
32, which is approximately 113.9. If you'd rather use, sorry, let me zoom out. If you'd rather use a decimal. So that is the horizontal distance. So looking back at our picture, it's going over 113 feet. We need to know how high is it at 113 feet. So if you know x, Libby, how can you find y?
You can put that.
Yeah, you can plug it in for x. So now that we took the time to find x, if we want to know what y is, we can take this number and plug it in. And if you'd rather use the 113.9, that's fine. Ka's answer is going to be more exact because she kept the fraction. And then plus 3/2. So you would plug it in your calculator, use at least that mathematical part, the computation part of the calculator. And you get approximately, I'll put little squiggles there, 104 feet. So the height of the ball would approximately be 104 feet, which I know you found with the calculator, which is great. The calculator is there to help you check your work, like verify that you found 104. But at this point, we need to be doing it algebraically. You've got to do the mental thinking as opposed to the calculator. So the other application problem was number 69. And that one, I think a lot of you did letter A fine. But then letter B, again, says find the unit price that will yield a maximum monthly revenue. Like the light's shining in and it's making it hard to see here. You could complete the square for this one, or you could use the same exact thing. So if you want to find the unit price that will yield a maximum revenue, then you would still use x equals negative b divided by 2a, or Cade completed the square in this one. I'm going to give Cade a shout out too. He completed the square with this negative 10p squared plus 1580p, and also was able to find the vertex once you complete the square. But you can use negative b divided by 2a. So you take the negative 1580 divided by 2 times negative 10, and that gives you 79. So both those problems, thinking a little outside the box, like how can you do it algebraically? Can it completing the square work, or is there another formula that we can use? Questions? Nice job. Kate, good job. Okay, so I would like to just kind of walk us through just a little review here. We're going to work on a couple of application problems today as well. And the applications we work on today, you can either complete the square or use negative b over 2a because it works for both. Completing the square works as well. So given the function, negative 4x squared plus 8x plus 1, mine was wrong, so I had to cross it off, had an error there. Place it in the form y equals a times x minus h quantity squared plus k form. Show all work. And then underneath it, it asks us to, after we do that, find the vertex, the axis of symmetry, the y-intercept, the x-intercept. So just quickly kind of going through this again. Chelsea went through it as well with us. We'd first make this a 0. Take the negative 1 to the other side, or take the 1 to the other side, make it negative. Pull out a negative 4, and then we have x squared minus 2x. So always move c over, always pull out the coefficient before you do anything else, and that's what I've done in the same step. So I took the 1 to the other side, I took out a negative 4. When you take out a negative number, just be careful with your signs. And then we're looking at b, dividing it by 2, and squaring it. So completing the square is b divided by 2 squared. The axis of symmetry is negative b divided by 2x. So they're two different formulas finding two different things. One's helping you complete the square, the other one's finding the axis of symmetry using the other form. Brandon, what number goes in the parentheses if we take negative b divided by 2? Then you square it and you get 1. But Brandon, on the other side, we are putting a...
Negative 4, so it would be negative 5.
Right, placing a negative 4 there, so that becomes negative 5. Remember, that's the little trick part to remember. Negative 4 times 1 gives us negative, or 4, and you place the negative 4 on the other side. So Brandon, this factored is negative 4 times?
X plus 1 plus 5.
How about x minus 1?
Minus 1.
Okay.
I had plus 2 in my name for some reason.
And then taking it to the other side gives us a plus 5. Questions with standard form. So just be careful. I think the common error is the negative, pulling out a negative, and also don't forget to multiply by that coefficient that you pulled out. So this is standard form. We have our a, the h, the k. So Grace, the vertex of this parabola is 1, 5. And the axis of symmetry is at 1. So the equation of the axis of symmetry is just x equals 1. It's an equation because it has that x equals. You don't have to give me a formula there. Just whatever the axis of symmetry is, whatever the formula or the equation for the line is, x equals And then Grace, an easy way to find the y-intercept is just? Right. So go back to the original form. I even have a little arrow in it right now. That value, C, that we moved to the other side as the first step for completing the square, C is your y-intercept. So the y-intercept, make sure you're writing it as an ordered pair, is 0, 1. Questions? Eris, how does the parabola open? Down. It creates a frown. Goes down. It's -4. It is Monday. This is true. So the parabola is stretching vertically. It's getting steeper because of the -4 there, but the negative also makes it go down. And then the last question says, find the x-intercepts algebraically. Show work below. Cross off that evil making decimal stuff. Yours doesn't say that. So if we're finding the x-intercepts, go back to the step prior to it being in standard form. That's this right here. That's what you'll use to find the x-intercept. So we completed the square. We're going to take that equation that we have, finish solving for x, because the x-intercepts can be found by completing the square and then just fully working through the question. So Chelsea, what would we do to solve for x here? So divide by -4 makes it positive 5/4 because it was -5 and -4. And then Chelsea? And the square root of 5/4 becomes? Yeah, there you go. Square root of 5/2. So making it an intercept means, Mrs. Kane being lazy here, make sure that the y value is 0 because that's what makes it an x-intercept. So I'm being lazy. I'm taking my answer in x equals form, and I'm just forcing it to be an intercept by giving the y value 0. So y-intercept is when x is 0. It's an ordered pair where the graph crosses the y-axis. An x-intercept is when y is 0. An ordered pair, 2 of them, where the graph crosses the y-axis on either side. Any questions with that problem? So a little refresher, completing the square, finding the information of the parabola. That would have been those 5 problems. Chelsea went over one of those 2. Then the other problem is very similar to the one Asia did, just different numbers. So if you're finding a quadratic function that has a vertex at 2, 3 and passes through a graph at 0, 2, how would you start it? Alice?
So you could plug in the 2 and the 3 for H and K.
Okay, so 2 and 3, vertex means it's special points. They represent H and K. It's negative when you place it in there, and the K stays as positive. What else, Alice?
Well, you're going, so it's going from point 0 to, so you plug the 0 in for x and the 2 in for y.
So you can plug those numbers in, and we don't know A. The other way would be to graph it, and you might be able to count to see what the vertical stretch is. So that would be another way to kind of approach the problem graphically. If you do it graphically, just make sure you have your graph showing how you're getting that value. But algebraically, Alice, -2 squared becomes 4. That 4, this is 4 here, is with A. Because right now it's A times that stuff in the parentheses. Make sure you keep it with A. A lot of people want to combine it with the 3 behind there. But that plus 3 is separate. They're not like terms. They cannot combine. And then we would take the 3 to the other side and divide, and Alice, the A value is? Thanks. -1/4. So the graph goes down. Again, it's negative, but this time 1/4 is less than 1, so our graph is going to open up wider. So A value is -1/4. The H was 2, and then the K is 3. Questions? So, I'm going to kind of explain to you what I want you to do with the rest of the class. On Wednesday, you have a little quiz. It looks identical to this worksheet, Nothing different, except the numbers change. But otherwise, it is exactly the same. I actually have 4 copies of this. So I have the original version. I have version A, B, C, and D. So if you'd like to do C and D, feel free to, because you're going to take B as your quiz. But I have extras if you'd like to work through any others, just to get an extra problem to go through. But there's also a review worksheet in your packet with some extra problems for you to go through as well. So 10-minute quiz on Wednesday. Everybody should get a 15 out of 15. Like, that's my goal. You know what it looks like. There should be no surprises. 15 points, 15 out of 15 for everybody. Your tests are graded. They're entered in PowerSchool. I'll give them back to you tomorrow. But today I want you to be able to kind of just focus on the activities that we're going to be working on for the rest of the 17, 18 minutes that we have. Questions? Okay, so in your packet there are 4 different pages that I want you to see and understand what you're doing with them. The first one is on page 9. And when you came in on page 9, hopefully you picked up a graph paper that had a whole bunch of boxes on it. This grid graph paper. Anybody not get the grid graph paper? Oh, good. Okay, so on page 9, this is an application problem, similar to the football problem, except you're going to be making your own graph and doing your own calculations algebraically. You can use the calculator to help and support your answer, to verify your answer, but I want to see the algebraic work. So the equation that's given is a model for the infant's birth weight during the first 2 weeks of life. And this is not just random data that Mrs. Page decided to come up with. These are like actual data to like formulate a model for when a baby's born, how much it weighs during those first 14 days. So you're going to graph that. Graph each point individually. Graph each 14 days so that you can see what's happening with the graph. So it might stay flat, maybe it goes up, maybe it dips down. But you're going to be graphing that. The first question is more of an opinion question. How do you think the information was obtained to create that equation? Question 2, graph it. Question 3, 4, and 5 is where I need to see work. Please don't just have an answer down. Even if it seems like the easiest piece of work that you have to do, I want to see where you're getting that answer. Feel free to use the calculator to check and verify your results. And then number 6 is another opinion question. So 3, 4, and 5 I want to have work for. This is 14 points. So the graph and the problems, 14 points for tomorrow. If you flip the next page, you can rip this next page out because you're going to be doing that with a partner or a group of 3 today, and you'll hand this in before you leave. It's 2 application problems that you'll be solving algebraically with a partner or a group of 3. So page 11, just the front, there's nothing on the back blank. You can rip that page out. And then pages 12 and 13 are review problems for you to work through. So a review of the section. And then finally, I know it's a lot, finally page 15 is an intro to what we're doing tomorrow. This should take you at most 4 minutes. It might even take 2. You're coming up with an equation that has an even power, like y equals x squared, and an odd power, like y equals x cubed. You could be creative and do y equals x to the 4th or y equals x to the 100. That would be fine too, because that would be odd. But you're going to pick an equation with an even power and be basic, like it doesn't have to be super huge and crazy. And any function with an odd power, you're going to plug it in the calculator, draw a little graph, and just kind of just look at that graph and decide what's happening. We did this last year. This exact page, it just wasn't formatted in this way. I think it was like left, right, with like 4 boxes instead. So max 4 minutes. Should not take you long. You're plugging something in the calculator, looking at the calculator, and just looking at it. Okay? So you have 15 minutes now. Work on the 2 questions. Those 2 questions should not take you very long. Hand in 1 per group if you're working with a group. If you're by yourself, just hand that in to me. And then start one of those pages that you have for homework.